Now, as I have explained for the quadratic equation ax square plus bx plus c equal to 0, we put it as 1, and x equal to, the solution of it comes as x equal to minus b plus minus b square minus 4ac upon 2a. So now you are seeing that x has two values. One is minus b plus root of b square minus 4ac upon 2a, and second is x equal to minus b square minus 4ac upon 2a. We put b square minus 4ac as d. So, and we call these two different equations and two different solutions as roots, alpha and beta. So alpha can be mentioned as minus b plus root of d upon 2a, and beta can be minus b minus root of d upon 2a, and a is not equal to 0. You will definitely ask me why a is not equal to 0. The a is not equal to 0 because in these two, alpha and beta, you will see if a is equal to 0, then these will be indeterminate or this will be infinity. So you won't be able to find a real value, or not exactly the real value, but the value which can be counted, a finite value. That's why. And second is, when you write the equation itself as ax square plus bx plus c equal to 0, and if a is equal to 0, then the equation will become bx plus c, and the highest power of x is 1 and c x raised to 0. It means the so-called quadratic will not become quadratic but a linear equation. Okay? Now coming back to, since d is called as discriminant, which is b square minus 4ac. So there are some conditions that in the roots alpha and beta, we have minus b plus root d upon 2a and minus b minus root d upon 2a. Now d can take three values, that is, it can be more than 0, it can be less than 0, it can be positive, it can be 0, it can be negative. When it is negative, then we are very much aware that root of minus d becomes a imaginary number. It is not a real number, because a real number in the sense that a number which can be in reality existing, but because of certain problems that further research was done and invention of unreal numbers or imaginary number has taken place, which we'll study later. Okay? So we want to find out now nature of roots, that is, what sort of roots we get as alpha and beta. Number one, A, B, C are the real number, means the coefficients are the numbers which have some value which can be recognized, which are in reality existing. And this sign shown is belongs to, like I mentioned it here, which you have to remember, belongs to. And R is a real number. So condition is that A, B, C belong to real number, family of real numbers, and A is not equal to 0, then equation 1, that is ax square plus bx plus c equal to 0, okay, has three conditions: either discriminant, that is d equal to b square minus 4ac, less than 0, equal to 0, and more than 0. We discuss these things separately. When d is less than 0, then automatically we have the roots alpha and beta as minus b plus minus d plus minus value upon 2a, and minus b minus minus of 2a minus of value upon 2a. It means that minus of d and root of it become the imaginary number. So we can't find the root, or there will be no real root. It will be an imaginary root which will be discussed later. Okay? So second thing is, when d is more than 0, then equation 1 has real roots. It means because square root and cube roots of positive values can be definitely found out, but square root of negative value cannot be found in the real form. So we say equation 1, when d is more than 0, then equation 1 has real and distinct. What is meaning of distinct? Distinct means which can be separately found. So there are some words which in mathematics you should be very clear about, like finite. Finite is which is countable. Distinct means which is recognizable, which can be separated from other numbers. Okay, so this will be equation 1 as real, means the value is in reality existing, and it is distinct, that is can be recognized mathematically, namely alpha and beta. Then a x square plus bx plus c equal to 0, we can write like this. A can be taken common and the roots will be x minus alpha, x minus beta equal to 0. Coming down to, if d is equal to 0, we have already discussed the conditions d less than 0, d more than 0. If d is equal to 0, then equation 1 has real and equal roots, because when d is equal to 0, our alpha and beta will become minus b upon 2a and minus ba upon 2a, means they are equal. At the same time, they are real, their values, because a, b and c are real and a is not equal to 0. So this same equation 1, that is ax square plus bx plus c, can be written as ax minus alpha or ax minus beta whole square. Okay. Now if a, b, c are belongs to q, q we write as ratio. That's why it is defined or it is said as rational number. Rational number is which has got denominator upon numerator. So in case of the denominator must not be equal to 0, so then the number is called as a rational number, and all the numbers can, whether negative, positive or even 0, can be written as rational number. Okay, so they are all rational numbers, means which can be written in the form of a ratio. And d is a perfect square. D is equal to 0, not a perfect square, but equation is a perfect square. D is a 0. Then the roots alpha and beta are rational. It means they will be also coming as rational, and the real number means it will be a ratio. Okay? And if d as such, d is not equal to 0, means d could be less than or d could be more than, and d is not less than but more than 0. If d less than, then the roots will be unreal. It will have a part of imaginary number. And if d is more than 0, then it is a real number, but it will not be rational. That is called as it is irrational. Roots are irrational. Now you will ask me naturally that what is irrational? You see, irrational which cannot be defined in the form of ratio. So I'll first explain you little bit about rational and irrational. Okay, let me run this. Now rational, as I've explained it, written in the form P upon Q, Q not equal to 0. Okay? In that case, you have numerator, that is upper part, and denominator that is lower part, or it is basically division. In a division you have a quotient and divider. Okay, now denominator is not equal to 0 and all the numbers can be set as rational number, like let us see 5 minus 9, 13, okay? They can also be written as 5 upon 1, minus 9 upon 1, 13 upon 1, okay? Now, when we write 4, 8, 16, 25, in these cases we find 4 can also be written as plus minus 2 whole square. 8 can be, 16 can be written as, 8 can be written as plus minus 2 root 2 whole square. 16 can be written as plus minus 4 whole square. 25 can be written as plus minus 5 whole square. Now looking at these numbers, if I find out the square root of it, then square root of 4 will be plus minus 2, which can be written as plus minus 2 upon 1. So this becomes a rational number. Or root 16, you will find same, equal to plus minus 4 upon 1 is rational number in the form of P upon Q. Okay? In case of root 25, right? But you have seen 8. In case of the 8, I have found, when I have found out the square root of 8, it becomes plus or minus 2 root 2. Means I can write as plus 2 into root plus root 2, or minus 2 into minus root 2, or it can be minus 2 into minus root 2 plus root 2, and it can also be plus 2 into minus root 2. Sorry. Looking at this, you will see that root 8 has 4 solutions. Plus 2 into minus root 2, 2 into plus 2 into root 2, both plus, both minus, and 1 minus 1 plus or 1 plus 1 minus. Okay? Now, finding answer for root 2. You will find that root 2 is 1.414 and it goes on but does not finish. The exact value of root 2, root 3, root 5, root 6, root 7 cannot be found out. So that is why they cannot be found in the ratio. No doubt, when we stop at 1.414 for root 2, we can definitely write it like removing decimal as 1414 upon 1000. That means it is a rational number. But since squaring 1.414, we may not reach exactly the rational number or the number 2, but maybe near it. The limit may be 2, but we are near it. That is why the exact value cannot be found out. And they are called as irrational numbers, means they cannot be specified as a ratio. The best example of irrational number, I just give you all the roots which are not perfect squares are irrational numbers. That is root 2, root 3, root 5, root 6, root 6, root 7, root 8. No root 9, because root 9 is perfect square of 3. Then 10, 11, all those things. At the same time, pi, which is well known for all mathematics students, that pi is found to be that a circumference or the boundary or the perimeter of any circle is divided by double the radius, or if it is divided by the radius itself, then it is pi times measurement of the radius. But mathematicians have found in the values in a different form. When we write pi itself, then it is an irrational number. But when we write it as 22 upon 7 or 3.14, then they can be mentioned or can be specified as rational numbers. So they are irrational as well as rational numbers. Okay? But generally pi has been recognized as irrational number. Now you can see I have mentioned that for other types of the natures of the roots, the equation itself is ax square plus bx plus c equal to 0. And a, b, c are the real numbers and a is not equal to 0. Okay? Number 5 is if p plus iq is one root of, that is alpha of the equation 1 is a complex root, then and q is not equal to 0, then the other root must be p minus iq, that is beta. Now you will definitely ask me that I have used number of words in it, that is complex root, and it is written as p plus iq and p minus iq. What is meaning of it? You see, we have defined real numbers, that which are the numbers which are really existing. This problem cropped up then when we were squaring any number or when we were finding the square root of a number. We did find that square root of positive numbers and the 0 could always be found out, but the square root of the negative number could never be found out, because square of any number cannot be negative. So finally we have come to a conclusion that we can generate or we can create some number which can be written as square root of negative number like negative 5, square root of positive 5, yes, square root is an irrational number. But in case of the negative 5, it can be written as negative 1 into positive 5. That can further be written as negative 1 into root 5 or square root of 5. So square root of 5 can be found out as irrational number. But what about multiplication with square root of minus 1? So that was defined as I, or imaginary number, or iota. So I is written as iota. Okay? And complex number is a number which has got two parts, negative and positive. Negative and, two parts as real and unreal, or real and imaginary number. That's why it is written as IQ. So when it is a combination of both of them, then we call it a complex number. Okay? And note down that they don't follow direct arithmetic rule like addition, subtraction, multiplication, division, whatever it is. Okay? So if the one root is P plus IQ, means a complex number which consists of real as well as imaginary part, then the other root will be its P minus IQ, that is unreal number, that is a conjugate number where one root is plus and other root is minus. So question can be or equation can be immediately solved with it. Second case is if same way A, B, C are real and P plus root Q. You see, like that in the complex number, in this case you have rational and irrational part. So when there are, root is combination of rational plus irrational part or rational minus irrational part. So automatically other root becomes conjugate of it. For plus it becomes P minus root Q, and for minus or beta it will come P minus root Q to P plus root Q. Okay? And root Q is called as a surd. Surd means it is irrational root of a rational number. It is said as irrational root of a rational number because the root has to be irrational. Some numbers, when looking directly, they may not be perfect square, but then they may be the combination of two numbers, so that its first root will be irrational. Okay? Then if A is equal to 1 and B and C are integers, now what is integer? You should know that from the number theory, the various numbers which have been defined, that is the natural number, whole numbers, integers. Integers are the number in which minus numbers, root and plus numbers come, like minus 3, minus 9, 2, 0 and plus 1, plus 3, 5. Okay? So if they are they are integers, then the roots are rational and integers. It means they will be rational and integers. You very well understand. Okay? Eighth is if the equation 1 has more than 2 roots. Now you will ask me, what is more than 2 roots? When quadratic has only 2 roots. Now when you further go for the complex numbers, that is combination of real and unreal numbers, that you will find it is trigonometrically specified in a different form. And there, since in trigonometry we deal with the angles, and we are very well aware around a point it is 360 degree or 2 pi radian angle. So after every 2 pi, the circle, the revolution repeats itself. So the values of trigonometric values repeat itself. That's why they will have number of roots, and this is called as an identity. Okay. I have written one example as find all roots of equation x raised to 4 minus 10x cube plus 30x square minus 22x minus 7 equal to 0. Now if I would not have written it equal to 0, then this would have become an expression in the highest degree as a 4. But while writing it 0, it becomes an equation. Okay? It means it will have solutions which will satisfy the left part to the right part. It means substituting that particular value or the solution or the root in this equation must satisfy that while counting or while calculating, the net result is 0. Okay? Now other condition given in the problem is if one root is 2 plus root 5. Now since we have the highest degree of x is 4, it means x can take minimum 4 values. It may be higher also, but in the case of higher, it becomes, unless until it is an identity, the higher values will not be there. But 4 values will definitely be there. Now question is, we are given only one root or one solution, that is 2 plus root 5. As per the nature of the roots which we have already explained you, 2 plus root 5. Now 2 is a rational number and root 5. Finding the square root of 5, it is a never ending. That's why it is called as irrational. It means it is a combination of rational and irrational. It means that it will have one other root as a conjugate. It means the other root is 2 minus root 5. Okay? Now both these roots are satisfying this equation. It means I can further write two factors of it, like x to 4 minus 10x cube plus 30x square minus 22x minus 7 equal to, these are two roots, so this must satisfy x plus root 5 as two factors which must satisfy, because you are very well aware any equation like quadratic is written as two factors, like a x minus alpha x minus beta. So same way a fourth power equation can be written as a x minus alpha, x minus beta, x minus gamma, x minus delta equal to 0. Okay? So taking this equation as, and in that case you are very well aware, when I write a, b, c, d equal to 0, then in that case possibilities are a 0, others may not be 0. A, b is 0, c, d may not be 0. A, b, c are 0, d may not be 0, or all a, b, c, d are 0. Now taking this as a, so two factors x minus alpha, x minus beta, we substitute in. Since a is 1 here, that's why it is not mentioned, or we need not mention. Okay? So I have the root x minus 2 plus root 5 equal to 0, or can be written as x minus 2 minus root 5 equal to 0. Now this side I have root 5, this side I have x minus 2. I can also write it like this. Or x square minus 4x plus 4 equal to 5. Basic which you have studied is factors a plus b whole square or minus b whole square equal to a square plus minus 2ab plus b square. Okay? So I get this further as x minus 4x minus 1 equal to 0. Okay, so then I get, if I find out for this quadratic alpha and beta, so alpha will become minus, here a is 1, b is minus 4 and c is minus 1. Okay, so I get alpha equal to minus b plus root of minus 4 whole square plus minus 4a, that is 1, and c is minus 1. Okay, upon 2 times 1. This becomes plus 4 plus 16 plus 4 upon 2. Can be further written as 4 plus, if I take out 2, then this becomes 4 plus 1 upon 2. Okay, so cancelling it, finally I get 2 plus root 5. Okay, which is already given to you. In case of the minus, again we get for it minus root 5. Now second part, this is where we get the solution for one root. Now for the conjugate root, we get separate. We get another quadratic equation. Let me explain you. So the conjugate root will have 2 minus root 5, okay, equal to 0, one of the factors. So I can say x minus 2 equal plus 5 root 5 equal to 0, or x minus 2 whole square equal to minus root 5 whole square. So this becomes x square minus 4x plus 4 equal to 5. Or x square minus 4x minus 1 equal to 0, where you get the same answer as other. Now, multiplying these two factors, x minus 2 plus root 5 2 roots and x minus 2 minus root 5 using the formula a plus b and a minus b. We finally get it x minus 2 whole square minus 5 equal to 0, which again comes as x square minus 4x plus 4 minus 5 equal to 0 leads to x square minus 4x minus 1 equal to 0. Okay? Now to find out the balance, two factors. This is a fourth degree equation. So we can divide this equation, quadratic equation which we have found to it, and find out the balance factors. Let us divide it. X square minus 10x cube plus 30x square minus 22x minus 7. Okay? Dividing it with x square minus 4x minus 1. Okay? Then we divide with x square. So we will get x4 minus 4x cube minus x square. Okay? Subtracting it like we do in the division, we'll get it minus 6x cube plus 31x square, and further bringing down minus 22x. We further remove minus 6x cube. So we get minus 6x into multiplying with this, we get minus 6x cube and plus 24x square and minus plus 6x. Removing by subtraction, we get it minus 7x square plus 7x square minus 28x. Okay? Multiplied with plus, and this minus 7 is brought down. Multiplied with plus 7, the other factor can be achieved like 7x square minus 28x minus 7. Subtracting it, we will get remainder 0. It means this is a clear factor, x square minus 6x plus 7. So we have got two quadratic, being the fourth degree, we have got two quadratic factors of it. That is x square minus 4x minus 1 and x square minus 6x plus 7. And both equal to 0. Okay? So the first quadratic, x square minus 4x minus 1 has 2 roots, 2 plus root 5 and 2 minus root 5. For the second equation, x square minus 6x plus 7, we have to find out the factors. Here we are very well aware a is not equal to 0 and equal to 1, and a is, we can write like this: a is equal to 1, not equal to 0, and b and c are minus 6, 7 real numbers. Okay? Now we can straight away factorize it also as x minus 6. Now we have to factorize because 7 can be divided, or 7 has got two factors only, 7 and 1. But either in case of the when you have plus, which will be taught to you later stages in the factorization, that when the product part is plus 7, then it has to be plus 1 and plus 7 as the factor, or minus 1 and minus 7. And when in the middle term is minus 6, then it is always numerical number is added. So we can't have, if we add 7 plus 1, 8, it becomes, we have got minus 6. That's why we have to try other way, that is writing the roots same way, that gamma is equal to minus b, that is minus 6, plus root of minus 6 whole square minus 4 times 1 into 7, okay, upon 2 into 1. That becomes that plus 6 plus this 36 minus 28 upon 2, or it becomes 6 plus root of 8 upon 2. This can be written as plus 3 root of 2 upon 2, root of 3, and root 2. Because this is 8. 8 is 4 into root 2, and 4 2 is taken out of the root. Therefore, root 2 will remain and 2 gets cancelled. So, other root automatically will be the conjugate. So, finally, all the 4 roots are 2 plus root 5, 2 minus root 5, 3 plus root 2, and 3 minus root 2. And if you substitute any value in this equation, you will get the end result as 0, whether you put this or you put this or you put this or you put this. Okay?